Hi, I'm Jen, and welcome to this course on analyzing data in Excel. Microsoft Excel is a powerful tool for all things data related. I started using Excel when I was asked to improve my team's performance and cut resources. Instead of randomly making cuts, I did a thorough analysis in Excel. I concluded that if we made a small change, we could drastically improve the conversion rates. This meant more sales, adding revenue with fewer costs. Before we start looking at the specifics within Excel, let's talk about the data analysis process. This is a handy framework that you can follow regardless of the data tool you choose. We'll take it step by step. Create a business plan. Sometimes this is given to you, but it helps to understand what we want to accomplish with the analysis. During this course, we will examine Kickstarter project data to discover what elements make a successful project. Get the data. Once you know what you're trying to solve, you have to get the appropriate data. This could be a standalone data set like we will use in this course, or it could include connecting to a database. It's easy to store multiple data sets within one Excel workbook. Explore the data. Once you have the data, you need to get familiar with it. We will review some easy steps to do that in Excel. Prepare the data. Now that you know what the data set includes, it will likely need some cleaning. We will cover some simple steps to get started on data prep. If you speak with most anyone working with data, this is considered one of the most tedious but necessary steps. The time spent in properly cleaning data will set you up for a much more efficient analysis later on. Analyze the data. This is the fun part of working with data. Here's where you work to answer the business problem. We'll use Excel to do calculations that will help us analyze past Kickstarter projects. This will help us understand how to build a successful campaign ourselves. Present the findings. Once you complete the analysis, you are ready to share your findings. Usually this includes data visualizations. It can take many forms: a simple report via email with a summary of the findings with a chart or two, a real-time dashboard, or an elaborate presentation such as an annual report. This course will focus on exploring, preparing, and analyzing stages. Let's cover a few tips that will help you navigate in Excel more easily, especially when you have large data sets with many rows and columns. As we start looking at the data set, there's some fancy formatting. The alternating row colors and bold header denotes this as a data table. To make managing and analyzing a group of related data easier, you can turn a range of cells into a data table. One of the great features of data tables is the ability to autofill formulas in a column. Use the arrow keys with the Control or Command button for PCs and Macs respectively, and you will jump to the next blank cell in that direction. If you have a lot of blank cells, be mindful you might not be at the end of your data set. Page up, down, left, and right keys are good alternatives for jumping blocks of rows or columns. The last two keyboard shortcuts to cover are Control or Command F and Control or Command G. They do similar but different things. If you need to go to a specific cell, use Control or Command G and enter in the cell label you want to go to. In contrast, if you have a value you're looking for, use Control or Command F. Please note, depending on the version of Excel you're using, the pop-up box for these shortcuts could appear in different locations. Let's practice. Let's start exploring the dataset. We will be using Kickstarter information for wearables projects throughout the course. Wearables are electronics that a person wears in some manner. Smartwatches, heat-sensing clothing, and glasses with an embedded camera are some common examples of wearable technology. As we start looking at the dataset, it can be hard to see if two columns have the same information. For example, if we look at the pledged and USD pledge columns, many of the values look similar. It's not efficient to scroll through hundreds, if not thousands of records to see if they are identical matches. That's what the exact function does for us. Functions are predefined formulas that perform calculations by using specific values called arguments in a particular order. The exact function is quite simple. It starts with an equal sign. This tells Excel you want to use a formula. Then type exact and open parentheses. Then you will enter the first value or cell you want to compare, followed by a comma, and then the second cell. Cells are labeled using letters for the column and numbers for the row. You can add more than 2 cells to compare, but keep in mind it will only return true or false. If you have more than 2 cells, it won't tell you where they don't match. As you can see, many of the records have matching amounts. If we explore to the left, we can see that not all amounts are provided in US dollars, explaining the ones that don't match. Next, we'll take a close look at the ID column, which represents the unique project identifier. Even though the column is set to left align, there appears to be some extra spaces in front of the IDs. You can use the trim function to get rid of those. The structure for the trim function is very straightforward. Type equals, trim, open parentheses, then select the cell you want to modify and close parentheses. The function trim is extremely useful because it removes any extra spaces at the beginning and end of the cell value. Please note it won't change any spaces within the cell content. Another useful function to consider is sort. You can take a list of project names and sort it alphabetically. To use the function, type equals, sort, open parentheses. Are you noticing a trend? Then this function is a little different because you have to give a range of cells you want to sort. In this case, B2 to B104. Use a colon to separate the start and end cells. In order to specify the ordering, you need to add two optional arguments. First is the sort index or column number you want to sort. Since we only have one column, it's 1 followed by a comma. If you want to arrange the columns to start counting on the first selected column, regardless of where it's located in the dataset. Then, for A to Z, or smallest to largest, enter 1. For Z to A, or largest to smallest, enter -1. This is what the result looks like. All projects are ordered alphabetically. Let's take sort one step further. Now we want an alphabetical list of project names, but only for projects that have more than 1,000 backers, and this in reverse alphabetical order. We can incorporate the filter function into our formula. In order to combine functions, we will need to create a nested formula. This means we will be using a function as part of another function. An important note to remember when working with nested formulas is that Excel executes them from the inside out. In this example, filter will be executed first, and then those results are used as an argument in sort. We want to filter the rows to just those with more than 1,000 backers. The filter syntax starts with equal filter open parentheses, the range to filter, since column C contains the number of backers for each project, and because there are 103 projects, our range will be C2 colon C104. Then the criteria we want to use, C2 colon C104 greater than 1,000, close parentheses. You can add an optional rule about what to include if empty, but it's not necessary in this scenario. Let's combine sort and filter. Now we include the filter formula that you just saw as the first argument of the sort function. Important to note here is that the starting range to filter now includes both columns B and C because we are sorting on column B and we are filtering on column C. The second argument, sort index, is the column number of the column we want to sort. In our example, there are 2 columns. We need to sort the first one. Now you give it a try. Let's get a better understanding of data types. In Excel, there are 4 primary data types. Text can include strings of characters or numbers that will be treated as text. You cannot do math functions on text fields. Numeric, all the number formats including integer, decimals, percentages, etc. Date includes both date and times. And Boolean. These are logic values of true or false. Oftentimes, Excel will apply a general data type label, but in order to make sure formulas behave properly, it's good practice to assign the correct specific data type. Quick tip: if you see values left aligned, then Excel is treating it as text. Centered is logical, and right aligned is numeric or date times. Sometimes a column may look as numeric or date times. Sometimes a column may look like a numeric value, but in reality, it shouldn't be treated as such. For example, if we look at the ID column, we see that it is right aligned and is considered a number. Since we won't need to perform any arithmetic, sum, average, etc. on the column, we are going to change the data type to text so it behaves like a string. The function is text, and the syntax is pretty simple. Equals text, open parentheses, then the cell you want to reassign. The next argument specifies the desired format, which in this case is 9 zeros wrapped in double quotation marks. Close parentheses. The 9 zeros represent the minimum number of characters in the ID field. There is a large list of format options that you can find on the Excel Help Center online for more details. Notice the column alignment shifted from left to right. Let's take a closer look at the USD pledged column. As the header implies, the column represents values in US dollars. However, notice how the data is all left aligned. What does this tell us about the data type? That's right, Excel is treating it like text data. Let's fix the data type so it is recognized as numeric. The function in this case is value, which converts a string text that represents a number to a number. The syntax is very straightforward. Equals value, open parentheses, then the cell you want to reassign, close parentheses. Now you see how the dollar signs are removed and the values have shifted to be right aligned. While this helps make the column a little more readable, notice how the decimal places vary from cell to cell. There's a handy function round that applies uniform formatting to the cell. In this case, we don't care about cents, so let's round to the nearest dollar. We're going to wrap the round function around the value formula we just made. The syntax starts with equal, round, open parentheses, then value, open parentheses, the cell you want to adjust, close parentheses, then the number of decimal places you want to include. In this case, we want 0 decimal places, then close parentheses again. Let's move on to some exercises. Welcome back! Let's review the first part of the data analysis process. First, we form a business question, then get the data and explore the data sets. This is what we did in first chapter. In this chapter, we will focus our efforts on cleaning the data in order to prep it for analysis. As mentioned earlier, cleaning and preparing data can be time-consuming and very detail-oriented. While it's tempting to jump straight into analysis, please believe me that you will end up creating more work for yourself in starting over multiple times. Or worse, you could develop a recommendation based on bad data. So now it's time to get our hands dirty and prep the Kickstarter dataset. We'll start with some text or string cleaning. One of the most popular operations performed on text fields is concatenating, which joins text strings together in a new cell. For example, it's common to have first names and last names in separate columns, but it can be useful to combine them. Concatenate can do that. Taking a look at our dataset, notice that the project ID is separate from the project names. Let's join them together using concatenate. The syntax is equals concatenate, open parentheses, followed by the text or cells you want to combine with each other, separated by a comma, then close parentheses. In this case, let's join A2 and B2. How does that look? Wouldn't it be better if we added a dash between the ID and name? We can do that by editing the formula, adding the hard-coded text between A2 and B2. You have to put the desired text in between double quotes. In this case, we added a space, dash, space as the second argument. Now we can more easily distinguish the ID from the name. There are three functions that all work similar ways, but with different outcomes. Whenever a field has data collected in an open text box, like most online forms, you quickly observe how many variations in capitalization people employ. Depending on your need, it's possible to standardize the formatting to all lowercase, all uppercase, or improper capitalization when you capitalize the first letter of each word and the rest is lowercase. Not surprisingly, the functions are lower, upper, and proper respectively. Here's what happens when we apply each of these functions to the city field. When the lower function is used, there are no capitals. When upper is used, all letters of the city name are capitals. And when using proper, only the first letter of each word is capitalized. Now you give it a try. Let's continue talking about cleaning text fields. Up until now, we modified all the characters in a cell, but sometimes you want to isolate a piece of the text string. Excel has many functions to help. We've been using the terms text and string interchangeably, but it might help to think about text fields as a chain where each link represents a location that can be anything, a character, symbol, or space, etc. So if we want to look at this project name, 3dmykicks-3dmykicks.com, how many links are there? You could count each element one by one, but that is difficult and tedious. Luckily, Excel has created a function for this. This function is called len, as in length. The syntax is equals len, open parentheses, the cell or text string you want to count, close parentheses. The result for this project name is 27. By itself, this information is interesting but not particularly useful. However, we can now use Use it in combination with other functions to extract only the portion of text we want. Looking again at 3dmykicks-3dmykicks.com, if we want just the project name, not including the website, we can use the left function. The syntax is equals left open parentheses, then the cell to extract from, followed by how many characters to extract starting from the left. In this case, it becomes equal left open parentheses, cell B2, len, open parentheses, in double quotes, 3dmykicks, close parentheses, twice. You might think this is a lot of work for something you could extract manually without any functions for a single instance. However, what happens if you have some imported data that looks like this? Clearly, there is something funky with the raw data, but it's easy to fix in Excel. Let's extract just the state information, leaving off the nonsense data. What's the length of the bad string? 7. Now let's use this information as we build the nested formula. Equal left open parentheses, M2 len open parentheses, M2 close parentheses, minus 7 close parentheses. The reason we are subtracting 7 from the total length is because each cell varies in length, but consistently has the bad string 7 spaces in length. We want the result to include everything to the left. The next function we'll discuss is right. It has a similar syntax to the left function. The big difference is that it starts counting the spaces from the right side instead of the left. The last common text function we'll discuss is substitute. As you can probably guess, the handy feature will look for a specified string within a cell and replace it with new text. Why is this useful? As you prepare data for analysis, it's vital to make sure formatting is consistent. For example, as we look through the project names, notice how some use a dash and others use a column to separate title and subtitle. The syntax for substitute starts with the cell reference, the old text you look for wrapped in double quotes, then the new text you also want wrapped in double quotes, and finally, you can specify how many times in a cell you want to modify the old text. Let's use substitute to change all the colons to dashes. Equal substitute open parentheses, B2, double quotes, colon, double quotes dash, double quotes, close parentheses. Notice the change? Also note that if there was no colon in the name, like the second row, then the cell didn't change at all. Now try out these string functions for yourself.
In this video, we'll learn all about working with date data. If your boss asks you to look at the project data by date, how would you interpret this request? Would you look at the data by launch date? Would you want to look at how long a project campaign ran? Maybe look at trends by year, month, day of the week. There are so many ways to think about dates in data analysis. It can be very useful to prepare the data set in the cleaning stage to be ready to look at it in any of these ways. First, let's look at the age of each project. We don't need a special function for this. It's as simple as subtracting the launch date from the deadline. For the first row of this example, that means E2 minus D2. This returns the number of days the project was active. But what happens if we want to know how many days ago the project ended? There are two functions that look the same on the surface, but give slightly different answers: now and today. These functions don't have any arguments, but we do need to include the open and close parentheses so that Excel knows we want the function. Let's try them out. First, try now minus the deadline. Then in the next cell, today minus the deadline. What looks different? How come we have partial days in the now column? It's because the now function returns the exact date and time, whereas the today function only returns the day. Depending on the date format you're working with, one may be better than the other. In our situation, we don't have any time data, so the today function works best. When analyzing date data, you can treat the dates in one of two ways: continuous or discrete. Continuous dates represent information over time, such as January 1st to January 31st. However, when we want to analyze date groups by month, day of the week, quarter, etc., this requires discrete date values so that you can use the unit of time as categories. The easiest way to transform date columns into discrete groups is to extract the relevant part of the date into a new column. The two most common units are months and day of the week. Excel has functions that can help easily do this: month and weekday. Please note the result from these functions is numbers representing the month or day of the week. The syntax for month function is very simple. You just have to include the date you want to extract the month from between parentheses. The months go logically from 1 for January to 12 for December. Later on in the course, we will learn how to show the actual month names.
The weekday function works in a similar fashion. It takes the date as the first argument and then return type as an optional argument, as denoted by the square brackets. But what does this optional argument do? The starting day for weekdays can differ depending on where you're located or your business need. Excel has considered this, and you can specify which day you want to start the week with. If you enter 1 or leave the argument blank, the week starts with Sunday. If you want to use, for example, Monday as the start of the week, the second argument in the formula should be 2. Now you give it a try. Welcome back. It's time to cover what I consider the most important function in Excel. Up until now, we have focused all our efforts on cleaning and preparing data within one data set. However, what VLOOKUP allows us to do is to incorporate data from another data set and then plug it into our working data set. This is why it's so important. In the last lesson, we added a column of the month from the launch date field. Let's use VLOOKUP to make those numbers into actual month names. We will need a new table of the list of months and numbers. See how I added the new tab called Date Tables. Before we put the function into practice, let's take a closer look at the syntax since it has more arguments than the previously used functions we've covered. What the heck does VLOOKUP mean? Vertical lookup. As the name implies, when you merge data together, Excel looks for the matching value between two columns or verticals, one in each data set. Don't worry if you don't understand that yet. We'll go into more detail looking at each argument that makes up the function. The first argument is the lookup value. This is the value on the destination dataset to match on. Next is the table array. This refers to the range of cells where the value is located that you will bring into the destination dataset. An important note to remember, the first column of the table array has to be the matching values. This does not have to be in column A, but just the first column in the range. The third argument on the formula is colnum. This refers to the number of the column of the data you want to return. The last element is called range lookup. It's a logical value, meaning you need to enter true or false. True means Excel will look for an approximate match. It assumes that your tables are sorted by the matching values and it puts in the nearest value. It is not used very often. More often we use false, which provides the result only if there is an exact match. Before we apply the VLOOKUP to our Kickstarter data, let's make sure we have matching columns for the month numbers. Column F, month, in the Kickstarter table, and column D, month number, in the months table on the Date Tables tab have the same values. In our example, the lookup value is F2, the specific month number for that row. Next, the data range is columns D and E from the Date Tables tab. Remember, we need to list the full range of data for both the matching value and the desired data. Since the data is located on another tab within the workbook, Excel automatically adds the tab name in single quotes and an exclamation point when you click on the range. The third argument is the column number. Column D is number 1 and column E is number 2. So we need to put in column 2. We want to match the month number exactly, so we will use false for the last argument. Now look at the Kickstarter data and notice all the month names. Before we practice VLOOKUP, let's make our dataset more efficient and calculate the month by name in one nested formula. Which argument in the VLOOKUP function would we put the month function? If you said lookup value, you're right. So the formula will look like this. Whenever possible, it's best to combine functions together to limit the number of columns in your dataset. VLOOKUP can be intimidating the first time you try it on your own, but have no fear. If you take it one argument at a time, it will work. The possibilities are limitless for how much data you can incorporate into your analysis from different tables. Give VLOOKUP a try. Welcome back to the third and final chapter. Let's check in on where we are in the data analysis process. So far, we have spent a lot of time exploring, cleaning, and preparing our Kickstarter data. Now we're going to do some analysis so we can better understand what makes a good Kickstarter project. This lesson will focus on counting. When doing analysis, it's important to understand how many records or values you have, and even look at how many blank cells you have can be informative. In Excel terms, count refers to the number of cells. However, there are a few variations of the count function that count based on different criteria. Let's take a closer look at each of these. Let's start with the basic count function. The function counts the number of cells that contain numbers in a given range. So pay attention to the data types in the cell range of interest. Count only counts numeric values. Here you can see the syntax as an example. The COUNT_A function counts the number of cells that are not empty in a range, regardless of the type of data it contains. The syntax is very similar to that of count. Here you can see an example. Lastly, there is COUNT_blank. As the name implies, it counts the number of blank or empty cells. Here you can see the syntax and an example. A few special notes on COUNT_blank. Cells with formulas that return double quotes twice, and empty text, are counted. Cells with 0 values are not counted. Let's apply all these functions to the same data range, namely the first 10 records of the goal and city fields. Does anything look wrong with the results? That's right. The COUNT_blank function hasn't captured all the supposedly blank cells. You should be mindful that sometimes people enter a space when inputting data into a database instead of leaving a field blank. When you discover this, you can take a step back from analyzing the data and go back into cleaning mode. As we covered in Chapter 1, you can use the trim function to ensure blank-looking cells are actually blank. In the real world, the data analysis process is not strictly linear. You often have to go back to clean or prep the data, or even go back further to refine the business question. Let's start counting. In this video, we'll discuss a number of aggregation functions that will help you summarize your data. You can certainly use Excel to do simple math like 2 plus 2. But now imagine you have a large number of cells to add. Wouldn't it be nice to be able to use a function? Luckily, Excel has a large number of math functions for us to use to choose from to make analysis easier. Why is it important to know how to do aggregate or math functions? Because it's a great way to make your analysis easier and to get a good understanding of your data set. All the aggregation functions in this lesson have a similar syntax. Start with the function name, then provide the data range you want to calculate. Let's focus on the goal data for our analysis. Starting with addition, there's the sum function. Here's the syntax and an example. Note that any cells that contain text or dates in the data range won't affect the function. Excel skips over those cells in the range when calculating the sum. In colloquial English, people often interchange the terms sum and count. You need to be mindful that the sum function adds the values in the selected range, whereas the count function counts the number of cells that contain a numeric value. Next, we're going to take the functions to the max. Well, to the max and min, actually. These functions often go hand in hand. Here you can see the syntax and an example. Max returns the largest value in the range, and min returns the smallest. Special note, if the range doesn't contain any numbers, both of these functions will return 0. Another common function is average. In school, you may have had to manually calculate the average or mean of a group of numbers. To do that, you had to add up all the values and then divide that sum by the count of values. In Excel, all you have to do is provide the range of cells you want to use, and it does all the calculating for you. Note that if you have blank cells in the range, they will not be included in the calculation. The last basic aggregation is median, the middle number of a group of numbers listed smallest to largest. Half the numbers have values that are greater than the median, and half the numbers have values that are less than the median. On the slide, you can see the syntax and an example. Maybe you've heard of median in demographic reports. Oftentimes, it's used as a point of comparison to average. For example, the 2018 median income per capita was $33,706. The mean income per capita was $50,431. Mean, or average, together with median, can help you understand the distribution of values. The closer these numbers are, the more evenly distributed the values are. If they are very far apart, the data set is likely skewed. Descriptive statistics is outside the scope of this course, but check out the linked article for more information. Let's get calculating. These the syntax, just value in the range. As we covered earlier, logic values are either true or false. In this video, we'll cover logic functions. These functions allow us to ask complex questions of our data. They analyze information and determine whether a certain set of criteria is met, returning either true or false. You probably don't realize how often you use this kind of logic all the time. For example, if your hand gets too close to a fire, then you move it away. If you don't, you might get hurt. Or if it's raining outside, you will use an umbrella on your walk. If you don't, you will get wet. In data analysis, you can ask Excel to make similar true-false determinations. For example, you can use a logical function to identify all the rows in which a project had more than 50 backers, or if a project is from the United Kingdom. So how do we do this in Excel? We use the if function. There are a few arguments in this function. The first argument is the criteria you want to test. The second argument is the value you want to return if the result of the test is true. The last argument is the value that needs to be returned if the result of the test is false. Let's look at a simple example. If the USD pledged amount, which can be found in cell I2, is greater than the goal amount, which can be found in cell J2, then we label the project a successful project. If the condition is not met, we assign the label failed project. Now let's make it a little more complicated. We are going to test the same criteria, but if the test proves true, we will show the dollar amount by which the pledge amount surpassed the goal. If the USD pledged is not higher than the goal amount, we'll show how much it fell short. As you can see, you can return text or calculations. Besides if, there are two other important functions, and or. Here you can see the syntax of the AND function. It can test multiple criteria at the same time. AND returns true if all the arguments evaluate to true, and false if one or more of the arguments evaluate to false. OR has a similar syntax, but now true is returned if any of the arguments evaluate to true, and false if all the arguments evaluate to false. If you want to test multiple criteria, it's common to use and or functions nested within the arguments of the if function. When you need all the criteria to be true, use the AND function. When you need only one of the criteria to be true, use the OR function. Let's take a look at how the nested if formula works with AND using our dataset. We want to test if a project is from the United Kingdom and raised more than $1,000. You start with if, and for the first argument, you will insert the AND function with both criteria you want to test. If both criteria are true, a value of yes is returned. If one or none of the criteria is true, the value no is returned. Your turn to start thinking logically. Now that you've mastered the if function, you might be asking how to combine some of the aggregation functions like count, sum, average with if. This way you can start doing analysis on the field level, not just cell by cell. Let's take a look. Let's calculate how many projects there are by country. To get started, we will need to create a table that lists all the countries in the dataset so we have some place to put the calculation. As you can probably guess, there's a useful function for that called unique. On the side, you can see the syntax and an example. This returns a list of all the unique values or names in the selected range. We can create our list of countries by selecting the country column as the data range. The unique function returns results in the order in which they are located in the array. Let's make the result look nicer by sorting it alphabetically. Do you remember what function we can wrap around the formula to do this? Yep, sort. Now that we have the destination table, let's add in the project count by country. To do this, we have to use the COUNTIF function. The COUNTIF function syntax requires the data range to count, then the criteria. In this example, we are using the country names as our criteria. This means that in cell T2, we are counting the number of cells in the country column, column M, that satisfies the condition that the country name is equal to in cell S2, Austria in this case. Note we have used the reference M:M to look at the entire column of data. Since we are restricting the results based on the specific country name, we don't have to restrict the range to just the specific range, as we have done in past lessons. What happens if we want the range that we test our criteria on to be different than the range of the calculation? For example, if we want to calculate the pledged average or sum by country, we can do this by adding the average if or sum if functions to our destination table. The syntax for both of these functions is similar. The first argument is the lookup range you want to test, in this case, the country column M. The next argument lists the criteria. Here, that is the specific country name from the destination table. For the second row, this is S2 or Austria. The third and last argument is the range on which we will calculate the sum and average. In this case, the USD pledge column I. Now, what happens if we have more than one criteria to consider? Let's figure out what the average pledged amount is by country, but only for successful projects. The function is average ifs. Note the s added to the end of the function name. That tells Excel you may have more than one criteria to test, but you can use this function when you have only one criteria to consider. Then the function will work the same as average if. In terms of syntax, average ifs start with the calculation range, then the first criteria range, then the first criteria. To add another criteria, just repeat the pattern of range and criteria. Let's look at an example. The calculation range is the USD pledged data, which is in column I. The first criteria range is the country in column M. The first criteria checks for the country name. The second criteria range is the status column P, and is followed by the test. To write a specific text test, use double quotes around the text you want to match. Excel is not case sensitive in this situation. Take note of the errors included. These appear because there is no successful projects in those countries. We have a summary table of valuable analysis in our dataset. Now you give it a try. Well done! Let's review what you've learned throughout the course. In Chapter 1, we discussed the data analysis process and started applying it by forming the business question, getting the dataset into Excel, and exploring the fields included in the Kickstarter dataset. In Chapter 2, we focused on cleaning the data. We covered a variety of functions to prepare text and date fields. Additionally, we learned how to add data into our dataset from another table with VLOOKUP. In Chapter 3, we got down to business and used an assortment of functions to analyze the Kickstarter data and better understand what features successful projects have in common. Look at all the many functions we covered throughout the course. This represents just a small portion of what Excel has to offer. Thank you for all the time you have dedicated to this course. It has been my pleasure working with you. I hope you now feel ready working with your own data in Excel. Good luck!